Okay, let's have a look at the question that involves triangle and part of a circle. So in this question, we have a shape, it's a curved shape, and we are told that that shape is made, that C is the center of the circular arc. So here it is, AC, AB. Now, what that is a sector of the circle. So not a full circle, it's a slice of a circle. And the same idea they are saying, we can look at it from A point, from B point. So let's say if I am looking from A point, A being the center, so that's A, and that's my circular arc. So again, as you can see, that's the shape, and the same idea will be from B. So all of them are exactly the same. Now, we are told as well that the dotted triangle ABC, so this triangle inside is equilateral triangle, and therefore they're asking us to write the size of the angle ACB. ACB, that's the one. Always remember where is that middle letter, that's where your angle is. Now, equilateral triangle, what we know about it is that every side have the same length and every angle is exactly the same. All angle in triangle add up to 180. So if I divide 180 into 3 equal angles, I'm going to get 60. So that means every actually angle in equilateral triangle is 60. Okay, and then the next part. The length of the straight line segment BC, so here, this length BC, is 40 centimeters. Now, that means that each one of them is 40 centimeters, isn't it? Because that's the equilateral triangle. Find the length of circular arc B2C. So what I am looking for is the arc. Now, how do we find that? Well, we go to the table and we look at for the formulas that have to do with the sector of the circle. So we go to our tables, and in the beginning, there it is. We have a sector and an arc. And here we have 4 different formulas. L, we have 2 formulas for L, and it's showing that L is that length. And then we have 2 formulas starting with A, and that means area. Now, we are not looking for the area, we are looking for that length. So which formula are we going to use? So beside these formulas is written when theta, and theta is what angle inside is given in radians. And then the second 2 formulas are saying when theta, when the angle given is in degrees. Now, our angle is in degrees because we know it's 60 degrees. So this is the formula we're going to use. So let's take that formula and let's see how we're going to use it, what that formula means. So that length L, that arc, the circular arc, will equal to multiply. Always remember, when there is no sign between the letters numbers, what do we have? Multiplication sign. Multiply by pi, multiply by radius. So where is the radius here? So we understand that this is the sector of the circle, isn't it? This is the center of the of that circle, and that is the slice of it. So not really particularly good drawing, but we get the idea. So that means that from the center to the edge is the radius, isn't it? Let's have a look again at our table. You can see it here that from the center to the edge, that's where we have R. So that means that this length is 40 because we are told each one of them is 40 because it's equilateral triangle. So that means that the radius is 40. So we multiply by 40 and we multiply, and the angle, again, look in your table, that's the angle if I'm looking for the length of the arc. So, this is the length of the arc I'm looking for. This is the angle, that's my theta, and we know that each of those angles is 60. Therefore, we are saying 60 divided by 360. And all we do, we put that in the calculator and to 2 decimal place. Remember, your calculator first will give you numbers with pi. Then you have to change that to a decimal. So to 2 decimal places, we should get 41.89. That is the length of our arc.